Question 3 says, the half-life of strontium-90 is 28 years. How long will it take a 50 milligram sample to decay to a mass of 32 milligrams? So I already have up our equation. This is the radioactive decay model. That's in the box above the problem, so make sure that you check that out. So let's first start by defining m of t. So m of t is going to be equal to, m0 is going to be 50 because that's how much we start with. E is there, negative, and I'm going to put r for now, and then t is going to be our variable, and then r is equal to, and it's ln of 2. It's always ln of 2, mainly because we're dealing with doubling time or halving time. So that's really where the 2 comes from, because you're taking half of the time. It's over h. H is the half-life, and they tell us that that's 28 years. So I actually want to take this value for r and plug it into r. So it's going to be kind of messy because we're going to have a lot of stuff in the exponent. But it will be m of t is equal to 50e, and then negative ln of 2 over 28 times t. And all of that is in the exponent. So that's our model. Now the question says, how long will it take to decay to a mass of 32? So they're actually asking for a t value as the final answer. So that 32 is going to be plugged in for m, or for m of t. So then I'm trying to solve for t here. So I want to divide both sides by 50, and we get 0.64 is equal to e negative ln of 2 over 28 times t. And then I want to take the ln of both sides. And this is going to work out kind of similar to number 1 on this worksheet. So ln of 0.64 is equal to ln of e raised to the negative ln of 2 over 28 raised to the t. So just like on number 1 on this worksheet, the ln of e will cancel out, and your exponent will just come down and be that side of the equation. So the ln of 0.64, that's not changing, that's going to be equal to the negative ln of 2 over 28 times t. So then to get t by itself, I want to multiply by the reciprocal. So I'm going to times by, let's do negative 28 over ln of 2. The negative sign, you can give it to the top or to the bottom or off to the side. As long as you don't give it to both the top and the bottom, then you're okay. So t is equal to negative 28 ln of 0.64 over ln of 2. And if you type that into your calculator, then you should get 18.03 years. So it will take 50 milligrams 18 years to decay to a mass of 32 milligrams. And this should kind of make sense, because if the half-life is 28 years, then that means that it takes 28 years for it to reduce down to half, or it would be 25 milligrams. So we're only reducing to 32. We're not going all the way down to 25. So it is going to take less, or it should take less than 28. So you can kind of use that as a check to see if your answer makes sense.